Severe earthquake in Venezuela and Colombia. Are we experiencing an epidemic of earthquakes? Just this year, we've had at least 10 major earthquakes in Japan, Malaysia, the Philippines, Mexico, Indonesia, and Tonga. Some of them were really bad, like the one in Venezuela that brought down a lot of buildings and killed a lot of people. So today, we're going to understand what's happening, why earthquakes occur, how they form, whether they can be predicted, and more. Is it true that there are no earthquakes in Brazil? Thousands of earthquakes happen every year. Just so you have an idea, in 2026, there have already been almost 10,000. Most of them we don't even hear about, okay? Because they're such weak tremors that we don't even feel them. The word earthquake comes from Latin, right? Terra means earth, and moto means movement. So earthquake is the movement of the earth, just like maremoto is a similar movement in the sea. But in science, the correct term is seismic event, or, as you might also hear, seismic tremors. But where do earthquakes come from? Does it have anything to do with what we're doing to the planet? Looking at our spherical planet from afar, this beauty, you might get the impression that it's practically like a marble, right? A ball of very hard stone, kind of like a perfect ball made of cobblestone from the Manuel do Mundo, right? An unbreakable rock. But that's not the case. Planet Earth is more like a brigadeiro. Right in the core, we actually have something hard, a little ball of iron and nickel. But around it, it's already something softer, something like dulce de leche, like toothpaste. The part where we live, which is more rigid, is just a thin shell around it, a really thin shell, the equivalent of an eggshell, really. That's what we call the crust. And the most important thing for us today to understand earthquakes is that the crust isn't a perfectly smooth shell all around, like a perfect egg. It's more like the shell of an egg you dropped that still didn't break. You know how the shell gets all cracked? Each piece of that shell we call a tectonic plate. And that's why I brought this unusual map here today, this colorful world map, which doesn't exactly show the outline of the continents, because this is the map of the tectonic plates. And most importantly, these plates aren't just sitting still, not at all. Our planet moves on the inside, and the plates move too. In fact, that's why if you look at the map, you'll notice that the coast of Brazil, this northeastern region of Brazil here, it fits perfectly right here in this little corner of Africa. That's not a coincidence. It's because Brazil used to be attached to Africa millions and millions of years ago, and it started to separate because these plates are moving. If these plates move, you might have imagined that when there's a division between one plate and another, something happens there, right? They collide, they rub against each other. One rides over the other, they slide. An example very close to home, okay? Here's the South American plate, and right next to it is the Nazca plate. The Nazca plate is in the Pacific Ocean, and the South American plate is in South America. The Nazca plate, it's going under the South American plate, so it's going underneath the other one. And do you know what we have right here? We have the Andes mountain range. Where one meets the other, it forms mountains. This movement is very slow, okay? You won't just stand there in the Andes and watch the mountain rise or one plate go under the other, no. It's all on a geological scale. We're talking about centimeters, sometimes millimeters per year. But there are several different ways these plates can interact. For example, here at the border between the North American plate and the Eurasian plate, okay? Eurasia, the name says it all, right? Europe and Asia are basically on top of a single plate here. The two plates are moving apart, and as soon as space opens up between the two plates, magma starts to rise up from below, right? This part that's underneath the plates, and it starts forming a region, filling up that space. So in this place, which is roughly in the region of Iceland on the globe, which would be here, look, we're going to have the formation of a mountain range under the sea, which we call the Mid-Atlantic Ridge. But if the plates are rubbing against each other, moving, why do we have earthquakes all the time? Because this movement suddenly releases energy. Let me give you an example here. An experiment I saw Bickman do when I was a kid, okay? Here, we have two plates and they're going to slide. The movement they make is a lateral sliding here, okay? But this sliding isn't that simple because the plates, they're kind of stuck to each other. So let's put a building here on top of one plate so we can see what happens to the building. And let's keep these plates barely sliding. more stuck together like it happens in real life, right? There's land on top, there's mountains, there are trees. The internal movement of the planet then makes these plates want to separate. They want to separate, they want to separate. They start bending, changing shape, trying to separate, until at some point this energy is released and we have an earthquake. The experiment is simple, but when I saw it on Bickman, if I could go back in time, I would try to give a like to his video. There was no like button back then, right? I had no idea it would have that kind of effect. With this example here, you must have realized that earthquakes are much more common where the plates meet. So if we look here at this world map of the plates, are earthquakes really at the meeting points, at the borders between the plates? The countries that have the most earthquakes are Japan, China, the Philippines, Indonesia, and Chile. And yes, these countries are exactly on the borders. Of the plates that are in this region here, the Pacific Plate, the Nazca Plate, the Philippine Plate, that's why there's an area here with volcanoes and earthquakes, which we call the Pacific Ring of Fire, which are the places that are on the edges and will have a lot of problems with these natural phenomena. The amount of energy that an earthquake can release, we measure in something called magnitude. This measurement is kind of complicated because it takes into account how much it's shaking and how much energy was released. But we can tell that earthquakes that are around 6, 7, and 8 are more serious earthquakes. The earthquake in Colombia was 7.4, and the earthquake in Venezuela was between 7.2 and 7.5, pretty much the same as Colombia. The magnitude scale has an interesting feature. 5 isn't just a little bigger than 4, it's 10 times bigger than 4. So 6 is 10 times bigger than 5, 7 is 10 times bigger than 6, and so on. So if we compare a magnitude 8 earthquake with a magnitude 4 earthquake, it's not just twice as strong. It's thousands and millions of times stronger. 10, 100, 1,000, 10,000 times stronger. The biggest earthquake we've ever been able to measure doesn't mean it was the biggest earthquake in the world, because there could have been bigger earthquakes at a time when we weren't able to measure them. But the one we were able to measure happened in southern Chile in 1960, and its magnitude was 9.5. One important thing is that a higher magnitude doesn't mean more people will die, okay? It depends on the depth of the quake. If it's very deep, it affects less. It depends if it happens in a place where there are a lot of people or not, if it can cause a tsunami, and if the buildings in the area are prepared for earthquakes. There's something that can happen to buildings called resonance, which is when the ground shakes in exactly the same way the building would shake. And this can completely destroy the structure. Look, we made a building simulator here with a 3D printer, okay? There are 3 different buildings, right? 3 different objects that shake in different ways. This is really interesting. I'm gonna put our new book back here just to give some contrast so you can see it better and get a little taste of what's inside our book. I haven't even made a video about it yet, but don't worry, there will be one. If I shake it slowly, only the first building moves. Look how crazy, the other 2 hardly move at all. If I shake it a little faster, look, it's the last one that will shake. And if I shake it even faster, I can make only the middle one move. Because it's like a child on a swing. You have to push the person on the swing exactly at the moment when the swing comes toward you. If you push at the wrong moment, it doesn't work, nothing builds up. That's what it means to get into resonance. It's like the building sways and the earthquake pushes again. The building sways, the earthquake pushes again. And then the effect on the structure will be much greater. The solution in engineering for this is to build buildings that aren't extremely rigid, okay? They can move during an earthquake, but they're already designed to absorb that movement, to work with that movement in an intelligent way. There are super modern buildings that even have a giant pendulum inside to control the building's movement during an earthquake. And then we notice a huge difference in places like Chile and Japan, which are countries that are much better prepared for earthquakes and build sturdier buildings, compared to when an earthquake happens in a poorer country, like the terrible earthquake that happened in Haiti, or now with the earthquake in Venezuela, which is also a very poor country. The buildings weren't built with earthquakes in mind. People aren't prepared to help. There aren't enough alarms or warnings in the city when an earthquake is happening, so everyone can get out, or designated places for everyone to stay at that moment. But these earthquakes that happen now in Colombia and Venezuela, Are they related to each other? Is it the same plate movement that caused the earthquake? No, it's a coincidence. The earthquake in Colombia happened because of that movement we talked about, with the Nazca plate going under the South American plate. And in Venezuela, it's friction between the South American plate and this little Caribbean plate here. There's no connection between one thing and the other. This sequence of earthquakes gives us the impression that something wrong is happening, that humans are doing something wrong, that the planet isn't well, and that there will be an epidemic of earthquakes. That's not what the data says, okay? Nowadays, we do record more earthquakes, but that's because we have advanced equipment that can detect earthquakes more easily. The equipment that measures earthquakes is the seismograph. In fact, we've already built one here on Manuel de Mundo using PVC to measure the sway of a bridge. Basically, it senses the tremor and records the movement like a device that shows heart rate. With technology, they've become more sensitive. 200 years ago, if an earthquake happened in the middle of the ocean or in the middle of the Amazon, in the Sahara Desert, in Antarctica, nobody would notice. Also, today we have much more access to news. So if an earthquake happens in Japan, even if it's not a very strong one, but someone films it, I don't know, in the middle of a surgery, the instruments start jumping on the surgeon's tray and then it goes viral. So you end up hearing about earthquakes that we wouldn't even pay much attention to. So regarding that, nothing very different is happening from what we've always seen. Every now and then there's a stronger earthquake, more serious, out there. But that's always been part of human history. But there's something else, right? The other day, Melissa, my youngest daughter, she's 7 years old, came to tell me she was afraid of global warming because there were so many earthquakes. The warming of the planet, yes, is something that humans are contributing to. But that has nothing to do with earthquakes. These movements that happen inside our planet, earthquakes, volcanic eruptions, and tsunamis, which are a consequence of earthquakes, have nothing to do with global warming. Humans can't do much about that. So it's not humans who are ruining the planet and causing earthquakes. And in the same way, these are things we can't predict very well. We know where they're more likely to happen, for example. We know that Japan is a country that has a lot of earthquakes. Chile has a lot of earthquakes. But we can't know when they're going to happen, just like with volcanic eruptions. You know the volcano is there, that it's active, but the day it's going to erupt, nobody knows. It's a little different with tsunamis because today, since we have such good communication and such good instruments to detect earthquakes, if an earthquake happens out in the middle of the Pacific Ocean, where nobody lives, you can measure it and warn the countries that will be affected. Warn Japan, warn Chile. Like, hey, an earthquake happened. There's a risk of a tsunami, but the wave that's going to be formed by the earthquake doesn't travel that fast. Sometimes it takes hours and hours for the tsunami to arrive. So people have time to get away from the sea and all that, so that when the tsunami arrives, people are much better prepared. There will be much less trouble, right? It destroys things and all, but people can survive. All right, but what about Brazil? What do we have to do with this? There are no earthquakes in Brazil. It never happens. Has it ever happened? I've never seen it. Well, Brazil got a bit lucky in this story. Our whole country is right in the middle of the South American plate. Not only are we on top of just one plate, but we're also pretty far from the plate boundaries. So Brazil is a country where earthquakes happen very rarely. But that doesn't mean they don't happen. In the last 10 years, we've recorded 2,000 earthquakes, or 2,000 seismic tremors in Brazil, but they're tremors that we barely felt. It's very rare to have any kind of earthquake in Brazil that people can actually notice. Doing some research here, we found out that the two biggest earthquakes that happened in Brazil were in Mato Grosso in 1955 and in Acre in 2022, which was 4 years ago. But they happened in places where very few people live, and they caused practically no damage, didn't kill anyone. Everything was fine. And maybe you're wondering, but why does it shake in Brazil, right? If it's entirely on top of the South American plate, it's not on the border. Because this plate isn't like a block of steel where nothing ever happens. It also has its little faults. It moves. Sometimes we feel an earthquake that happens somewhere else. It shakes here too. So this little movement of rocks and all, it can happen a little inside the plate itself, and that's what happens in Brazil. If you've made it this far in like history, geography, geology, we have some really cool books from Manuel de Mundo. So just to remind you, the big history book is part of that wonderful collection of great books we have. The Atlas, for those who like geography, Came out recently.
And geology, we'll have it in the first volume of the Britannica Encyclopedia for the Curious, explaining here how things work inside our planet.
There's even a section here just about earthquakes and tsunamis. Look how nice: tectonic plates, volcanoes, earthquakes and tsunamis, mountain formation, rocks and minerals. I could make this video just based on this book here. The link to all of them is down below, all right? We're making these videos to understand a little more about the phenomena of our planet. And the last really cool one we recorded is about El Nino. A really strong El Nino is coming. They're calling it Super El Nino. But after all, what is El Nino? Where did it come from? Why does it have that name? We explain everything in this video here.